Hi, my name is Anthony. I'm in the final year of Bandung Institute of Technology Mathematics Undergraduate Study Program. Today I will be talking about my thesis project that is Abstractive Indonesian News Summarization using PEGASUS. Have you ever felt overwhelmed by the amount of information you need to read in a day, or wish there was an easier way to get a gist of a long article or news story? Human attention span for reading cannot keep up with the amount of text data available on the internet. By reading the summary of a document, we can conserve our time and energy, therefore increasing our productivity. Thankfully, there's a lot of summarization tools available on the internet to help us. Those kind of tools use rule-based algorithm to generate extractive summary. Extractive summary works by taking pieces of information in the original document, like the sentences or phrases, to construct a new summary. We can see the generated summary, in a sense, is a subset of the original document. On the other hand, human-generated summary, or often called abstractive summary, the summarizer has an understanding over the article, and paraphrasing happens when constructing the summary. Extractive summaries are considered superior in terms of coherence, fluency, flexibility of the summary, and it also can handle longer documents well, but it's a challenging problem for machines to generate this kind of summary. A paper named PEGASUS, pre-trained with extracted gap sentences for abstractive summarization, appeared in International Conference on Machine Learning 2020, surprised the AI community by the breakthroughs in the abstractive summarization task. PEGASUS is a deep learning model that uses transformer encoder-decoder architecture, which takes in the sequence of input tokens and generates a sequence of output tokens. This is particularly useful for summarization, where the goal is to take a long piece of text and generate a shorter summary. Made by the Google AI research team, the model achieved performance close to the state-of-the-art with remarkably less labeled training data, around 1,000 data, compared to the previous state-of-the-art model which used tens of thousands of labeled data. In this thesis, I will implement Pegasus model to summarize Indonesian news. According to the study conducted by Indonesian Internet Service Providers Association in 2019, only 35.2% of Indonesian internet users accessed news websites or online newspapers. By making a tool for summarizing Indonesian news, it is expected that they will have more motivation to read the news and increasing productivity for regular news reader. And the expected results for this thesis are pre-trained Pegasus model for Bahasa Indonesia, fine-tuned Pegasus model for summarizing Bahasa Indonesia news, sample of Indonesian news summaries generated by the model. And next, here's how language model generally work. We have pre-training and fine-tuning. First, we will pre-train the model on a large corpus of text to gain general understanding of the language. The important thing here is the large corpus of text is unlabeled and it's easy to collect those data from the internet. The next step is we fine-tune for the specific task we want the model to learn using labeled data. In this case, we want the model to generate abstractive summary for Indonesian news. We will use document summary pair to fine-tune our model. Pegasus authors hypothesize that having custom pre-training function that is similar to the final task will give better results with less data. Pegasus authors propose a new pre-training task, gap sentence generation. For other large language models like GPT-3 from OpenAI and BERT from Google, they trained the model using mass language modeling. In the case of mass language modeling, the language model is trained to predict a token behind a mass that is chosen randomly. Gap sentence generation, on the other hand, match the whole sentence. The matched sentences are chosen to be some of the most important sentences in the document, making it a pseudo-summary. Predicting a whole sentence sounds a hard thing to do even for humans, but unexpectedly, this brings us really close to the final task of abstractive summarization. The strategy to choose the important sentence in the document is by choosing the highest row score. ROUGE, or Recall-Oriented Understudy for Listing Evaluation, measures the similarity between two documents. Here's the example for unigram model. Here we have the machine-generated summary and reference summary 1 and 2. First, we count the number of unigrams or words that overlap in the summary and the references, and then we can calculate the row 1 precision, recall, and F1 score using the formula below. Finally, for the steps in the modeling, first we have to clean the data by making it lowercase, removing links, HTML text and symbols. And then we have to tokenize it. We convert the word into tokens or numerical vectors so the model can process it at input. And then we have collating. We have to match the sentences and we have to batch the input so it's ready to be fed to the model in the training step. And finally, we have the evaluating step. We use the ROUGE metric to evaluate the generated summary. In conclusion, Pegasus model has shown the great potential for abstractive summarization and will empower Indonesians by generating high-quality summary of news and other long documents in a matter of seconds. Thank you.